Refraction, the bending of light. You can see over here how the glass is acting as a lens. And over here it looks like the straw is broken. And here's some ugly face. Pass a single beam through a rectangular prism and notice how it changes direction. This is called refraction. There's the prism, and that's how the light refracted. It changed direction. We draw normals at the two surfaces, and we find that light, when it's entering, bends towards the normal. What do we mean by that? Instead of going straight on, it bends closer to this normal line. And when it exits, instead of going straight, it bends away from the normal. We also had a bit of reflection at the first surface. Refraction occurs because light changes speed upon entering a different medium, a medium with different optical density, and it changes direction in such a way that this little angle is bigger than that one. So it's bent again towards the normal and away from the normal as it exits. In the triangular prism, we see the light ray bends towards the normal, and here it doesn't go straight but bends away from the normal. We also have a bit of reflection at the first surface and on the inside of this surface, and refracting there again, and this we call internal reflection. And if we get the angle right, you can see the dispersion of white light into its colors: violet, indigo, blue, green, yellow, orange, and red. Multiple rays show how a convex lens focuses the rays. And here's one with a shorter focal length and a diverging or concave lens, which is thinner in the middle. We can determine the focal length of a convex lens by focusing the image of a distant illuminated object like the window, and it makes an inverted image, like you can see the thumbs up shadow. Here we're inserting a lens between a candle and a screen. Notice the inverted image of the candle on the screen, and as the candle moves closer, we have to move the screen further apart, and the inverted image gets bigger and bigger. Until finally, when we go closer than the focal length, there is no image that can be focused. But if we look the other way around, we can see an enlarged upright image. And this is how a magnifying glass works, that we can use to enlarge images like reading, but we have to move it around and can only see a small amount of the text. But a far cleverer idea is a Fresnel lens that allows us to see the whole sentence or the width of the book. And yours truly, close up with a magnifier. Oops, sorry, I think I need a dentist. And here with a Fresnel lens. Gives you a much wider angle, suitable for reading. All of 50 Rand at the Crazy Store. Very clever lens, used in overhead projectors and lighthouses. And that's it so far. Thanks for joining us.